Good afternoon, sir.
Thank you.
Good afternoon, sir.
Good afternoon, ma'am. Good afternoon. So we were seeing about the different types of machine learning techniques, and last class we saw about unsupervised learning methodologies. Can I expect one difference between supervised learning methodologies and unsupervised learning methodologies from any one of you? Can anyone unmute your mic and tell me one basic difference between supervised and unsupervised, whatever you want?
No labels are given.
Yes, yes, Tawfiq.
So labels are not given in unsupervised.
Labels are not given in unsupervised, but what happens in supervised?
Labels are given.
Yeah, Tawfiq. Thanks. Thank you very much, Tawfiq. So that is the basic difference between your supervised and unsupervised learning methodologies, right? So last class we saw about unsupervised learning methodologies, which is exactly the opposite or contradictory ideas of your supervised learning approaches. As Tawfiq rightly pointed out, we do not have any labels, or we do not need any labels for the training process. But because of that, we have some drawbacks and at the same time some advantages too. So because you don't have labels, you don't have target, and you don't have the concept of error, and that's why we say that unsupervised are less accurate in comparison with your supervised learning methodologies. Because only if you have an error or something like an system in which you are going to say that whether it is good or bad, you can judge whether you are moving in the right direction or not. But it is not possible, so it is less accurate. And at the same time, the positive point is we need not go for a repetitive process. Say, for example, more number of iterations. All are repetitive only, but the supervised requires more iterations because it will have an objective to reach an error value of 0. 0 is not practically possible, but theoretically we say we are going to achieve an error value of 0. So it makes unsupervised a bit less computationally expensive in comparison to your supervised learning methodologies. And in supervised, we saw that it is useful for classification and regression type of application. So many applications, but these all those comes under these two categories. And at the same time, when you go for your unsupervised methodologies, it comes under the category of clustering, right? So always keep in your mind, you must know the difference between classification and clustering. Both will look same, but we have a small difference. Classification is specific. It can point out whether what is what, but when you go for clustering, it is more generic and it needs the concept of similarity measures to put all those data or on input or whatever it may be into some specific categories. So this is the main idea of clustering when you go for your unsupervised methodology. If you ask me whether we can do clustering with supervised, 95% of the time, no. But nowadays, people are looking for some hybrid of methodologies by which we can go for some research-based output. But for the time being, you should put clustering under unsupervised methodology. And also, the next application is association. As we saw, there are many applications in which when we get some data, right, we can associate some other data with that and then come to a conclusion, like what we have in our recommendation system, online purchase or anything like that. Most of the e-commerce or online business are depending on this type of unsupervised learning methodologies, right? So once you get an idea of classification, regression, clustering, and association, you will be confident enough in choosing which machine learning methodology is suitable for your specific application. Then we saw a comparison between supervised and unsupervised and different types of applications. So today we will be seeing the third major type of machine learning approach called as reinforcement learning approach. It is completely, what to say, it is in a different domain. The pattern is slightly different, and most of the reinforcement learning approaches are still under research. Right? Maybe I can say that it is a higher order machine learning approach. So my advice is, if for this semester you can concentrate more on the supervised and the unsupervised methodologies. Once you get a grip on these two things, then you can go into the next level of reinforcement learning approaches, right? But anyway, we must get some idea on what is reinforcement learning all about and how it is different from supervised and unsupervised methodologies. That's what we are going to see today in our class. Let me share my screen. Please don't come late. Is my screen visible?
Yes, sir.
Okay. So now we will go into the concept of reinforcement learning. So for supervised learning and unsupervised learning, I explained you with the help of the definitions, theoretical concepts, and then I went into the application part, right? But we are going to do the reverse in reinforcement learning. Only then it will be easy to grasp some information about this reinforcement learning. Have you seen this anywhere? Have you seen this anywhere? What is this? This is a very famous computer game, right? Maybe I am not sure whether you have seen all these things things now. So you are now.
Minecraft.
Pardon?
Minecraft.
Yeah, right. Oh, very old computer game. Maybe you people will not be interested to that. When you have PUBG and all those games, these are very much outdated. Right? Maybe when I was a small boy, these games are very famous. And Super Mario game is also another stuff, right? So the purpose of this game, the objective of this game is there will be a man, right? The user, the one who is, if I'm using a joystick, then I will be that specific person, right? And my duty is to reach the diamond, right? A diamond may be there, sometimes it may be a burger or some food may be there, anything, right? But my condition is in which path should I go? Which path should I choose in such a way that I can overcome the hurdles? When I go into this fire, there are 3 fires in between the starting point and the ending point. So I need to choose a path and I should make sure that I do not enter into the fire. Right? If I enter into the fire, I get some negative points. Right? So when I get some negative points or I may miss a life, when I get a negative points or I miss a life, then I will know that this is not the correct path. Then I will change my path. Right? Likewise, I will try to make sure that with less hurdles, I'm going to reach the final output or final reward. Right? So the problem is as follows. We have an agent. Technically speaking, we call this person or the robot in this picture as an agent. And he is having a reward. Reward in the sense, the final diamond with many hurdles in between. The agent is supposed to find the best possible path to reach the reward. So the outputs for this type of application is not the diamond. It is not the diamond. The output is nothing but which is the best path, right? Which is the best path. So there are many paths available. There are many paths available, but which path should I choose so that I will get a reward? So this agent, first time he will choose a path, right? Say, for example, he enters the fire. Now, immediately he gets a feedback. What is the feedback? A negative marking. So when I get a negative feedback, now I learn. Now I change my path and then go take another path. If that is a correct path, then I will get some positive feedback. So this process of learning continues. Each time I take a decision, I will be getting negative feedback or positive feedback, and based on that, I will change my direction and finally reach my reward, right? And the final best output, when I say the network is learned, is nothing but the best path. I'm trying to find the best path. It is not a single output, but when you say reinforcement learning, it is a continuous output, because among many paths, we are going to choose the best path, which may have more than one blocks in this specific example. That's how it is going to be different from your supervised and unsupervised learning. All applications which has multiple solutions, and choosing one from the multiple solution comes under the category of reinforcement learning. Say, for example, you are traveling from Coimbatore to Karunia, right? Coimbatore to Karunia. So which path you should take? There are many places in between. You have Peru, you have Alandura, you have some villages within that also. When you travel by some buses, I'm sure that it will take you through the villages and then come back and travel. So you choose, okay, let me go in that bus, right? So that learning procedure, by having some positive feedback and negative feedback, is called as reinforcement learning. So the previous image shows the robot, the diamond, and the fire. The goal of the robot is to get the reward, that is the diamond, and avoid the hurdles that are fire. The robot learns, or the machine learns, by trying all possible paths, right? By trying all possible paths and then choosing the path which gives him the reward with the least hurdles. Each right step will give the robot a reward or a positive feedback, and each wrong step will subtract the reward of the robot, or it will give a negative feedback. This concept of positive feedback and negative feedback is not there in supervised or unsupervised, right? In supervised, what happens? I give you a target, right? Now it is your duty to go and reach the target. In between, I will never interfere, right? I will tell you, go, this is the target. But when you go for reinforcement learning, each time I'm going to give you a positive and a negative, positive or a negative feedback, depending upon the decision you have taken. If you have taken a wrong decision, you will get a negative feedback, and based on that, again, the same process, you are going to change and try to find the best optimal path, right? So the another difference is, when you go for supervised or unsupervised, your output is a single value, but when you go for reinforcement, most of the time it is going to be a continuous value, a series of outputs you will get, which corresponds to one specific path. The total reward will be calculated when it reaches the final reward, that is the diamond, right? So this reinforcement learning is an upcoming area of machine learning, right? They thought we have some advantages with supervised, we have some advantages with unsupervised. Why don't we have a method which will have the advantages of both supervised and unsupervised? With that objective, this reinforcement learning came into existence. But I am not sure whether it has fulfilled that, but still people are working more on this reinforcement learning now, right? Because we have a positive and a negative feedback, we may think it as a target. Or because if you do not think it is a target, you may feel like putting it under unsupervised category. So it is somewhere in between your supervised and unsupervised. So specific solution, remember, the outputs are nothing but the paths in which you are going to reach the specific situation. Diamond is not important for us. The way in which you are going to reach the solution is the important point, or important area of reinforcement. So reinforcement learning differs from supervised learning in a way that in supervised learning, the training data has the answer key. What is the answer key? As per Taufik, it will be the label. It is the label. In supervised learning, the data and the name will be there, so that the model is trained with the correct answer itself. Whereas in reinforcement learning, I am not going to give much importance to the diamond, right? But I am helping you each time. That means I am going to be dynamic. Your states or your decisions are going to be dynamic. Every time you ask me, like how our children ask, is it correct? Is it correct? Is it correct? I will say yes, or I will say no. Right? So when I keep on saying yes, 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 you will reach the final output. That means indirectly you can say it seems like you are having a target, but you do not actually have a target. only you will have a positive or a negative feedback. That's why we say there is no answer, but the reinforcement agent decides what to perform with a given task from its experience. The man is going to decide what to do, what decision I should take, whether I move forward or whether I should move sideward so that I can reach the final reward. So when you put these terms, this concept of a game in a technical way, what should be the input? The input is not the agent. You may think like that the input is the agent from my previous explanations, but it is not the agent. What decision he is going to make? What decision he is going to make? When the, say for example, agent is in the bottom corner. Okay, fine. That is the initial state. Now he moves one step above. Now he gets a feedback. Maybe it is positive. Then he is getting a positive feedback for the next step. What is the input? Not the previous state. The current state in which he is now situated or located. That means the agent is not important. The position of the agent is important. We have some applications, I will tell you later, in which the positions of the data is important rather than the specific agent. And what is your output? Not the diamond. In our supervised and unsupervised, it looks like agent and a super diamond are the input and the target, and we are trying to move towards that. That's fine. But here the concept is slightly different. The output is we are not bothered about the diamond, but in which way the possible output are variety of solutions to a particular problem. You will have variety of solutions, variety of ways, but which way you are going to take does matter. That is the main objective of that game. Within less hurdles, you must reach one. So training, where does learning happens here? Based upon the input, right? That means the input is going to change. Based upon the position of the input, the model, the complete system is going to return a state. State in the sense, it will give you a feedback and its position, right? And its determination. And the user will decide to reward or punish the model based on its output. So when I take a decision or when my input position is changed, I am going to get some output, right? Based on that, whether I will get a positive or a negative feedback. This is how your model continues to learn by getting some positive, negative feedbacks, and this goes on. The best solution is decided based on the maximum reward. That means I should not enter the fire. Even by entering the fire, I may come to the solution. But if that is the case, then my points will be reduced. So how can I reach the final destination with the maximum reward, with less hindrance? So another difference you can have, it is all about making decisions sequentially, right? It is sequentially. That means sequence. It is going to be continuous. In simple words, we can say that the output depends on the current input, state of the current input. That means your input is going to change. Whereas in supervised and unsupervised, when input is there, you cannot change that. And the next input depends upon the output of the previous input, right? So based on the previous input, you are going to take a decision. Based on that, I'm going to decide where I should go next. Best example is the chess game, right? When you move soldier based on the feedback, what is the feedback? The opponent's move and the opponent's position, right? Now, okay, let me go for this move. We can move our pawn or so, anything like that, king or queen, and we can go for a next position. But in supervised learning, the decision is made on the initial input or the input given at the start. Interesting concept, right? Input will not change when you go for supervised learning, but when you go for reinforcement learning, it is going to be adaptive or dynamic. For example, any object recognition comes under, as we saw, face recognition, all those things come under. So these are some applications which I think we can deal it a bit later. It is used in robotics for industrial automation. It is used for data processing and for custom instruction according to the requirement of the students, right? So you people say that the food is not good in the hostel or mess, then the mess warden will take okay, what is the requirement of the students? So based on that, there is a chance that they may change. Or even in your home, you say to your mother that this is not tasty, then she may try to change that. That is an adaptive learning process. But it is an adaptive learning process. So this is the block diagram which I want to show. Right? If I show you the block diagram first, that may be a bit difficult for you to grasp the concept, right? But now I think you can understand the concept. You have an agent, right? Agent is the man or the robot. He is going to take an action, right? This action is nothing but the input. This action is nothing but the input. So a suffix t means iteration. We are going to move in an iterative manner. So the first state initially is taking an action, and when you encounter with an environment, right? Environment in the sense that board game, the diamond, fire, all those stuffs. When you encounter that by moving a step forward, you are going to get a reward. Reward means it may be either a positive or a negative thing, and at the same time the new position also can be determined by the agent based on the reward. Again, he changes the decision, and then the process keep on continuing till you find that you have reached the reward, or you can stop based on the application, whatever you have. This is a simple example for your reinforcement learning. You are walking on the road, right? Suddenly a dog barks, right? Dog barks. Dog barks. You have a noun and you have a verb. Now, which is the input? Which is the input? Is the noun or the verb? The noun is not the input, right? Dog is not important for us. Whatever action it is taking is important for us, because based on the action, the entire training process is going to get initiated. If it is not barking, there will not be any process. So barking plays a major role. It takes an action, it barks, right? Now the environment is you are walking, and when the dog is barking, you feel scared and you take a stick or a stone in your hand, right? Now when the girl or you take a stick in your hand, now immediately the dog sees and it finds that it is a negative feedback. It is a negative feedback. The reward it is going to get from that girl or you, if you are in that specific situation, is negative. And also the observation. What is the observation? She is having a stick in her hand. She is having a stick in her hand. So I know that it is negative, and she is having a stick in her. So based on these two things, again I am going to take another action. The dog remains the same. The dog will not change because it is not important for us. The action changes, right? If I find that the stick is not strong enough to hit me, then what will I do? I still bark louder, right? Now what may happen? The person may start running, thinking that, okay, the dog is much more stronger than me. Now what happens? The reward is going to be positive for the dog. Its objective is fulfilled. Now it sees again no stick or no stone. The girl is running. It starts chasing. The objective is a simple example for you to get the concept of reinforcement learning. The same thing when you have a maze, right? And you have a rat or a mouse which is trying to take the cheese which is kept in the maze, right? So it goes in different path. Right? It walks, it moves in different paths. Say, for example, it moves left hand side. Then when it encounters the environment, there may be a door there, right? That means you cannot move further. Then it's a blockage. So when you see a blockage, it's a negative feedback. Okay, let me come back or move in another direction, right? So that is the way how it is going to reach the cheese. More examples I can give you for this reinforcement learning. How a cat, when you have some fish in your home, or when you have some milk in your home, if you have a cat, definitely it will immediately say, it will start saying or making its own sound meow, and it will come towards your kitchen, right? But it will not know where it has been kept or where it is hidden. It will move around and try to find the state. What happens? A learning process is happening. So cat is the agent, right? It is an agent. It is not the input for us when you go for practical implementation. But the action, what it takes, it starts walking. The verb, the noun is there, the verb is important for us. It starts walking. So when it walks, in which way it walks? There may be many ways. Maybe it may jump over your pots or vessels, or maybe staying calm at some time, looking where these people are kept, or smelling those things. Then sometimes it may move away from the fish or the milk. Then maybe the smelling intensity, we do not know, right? The intensity of the smell would have reduced. Then it will take another way. Likewise, it is going to take the fish. This is an example for reinforcement learning. Or it is also used in the business purpose, right? In the stock exchange, people nowadays invest most of their money in the stock exchange. So each day, that's why I told you this is going to be a continuous output, not like your supervised or unsupervised. These people, if you watch news, they will see many people sitting together, and there will be like some advertisements will be going on, BSC, some values will be going on. They will keep on checking, and they will check whether they should sell or acquire. Right? So they look at the data, right? The person is there, but the action they are taking is they are looking at the data, and based on the data, they are taking a decision, selling. Say, for example, they are selling their stock. Now what happens? Another stock may increase, or this stock may immediately boom. That means it is going to be a negative feedback. And they will also know the rate, how much it has been reduced. Oh, I made a mistake. Immediately, then again, they may go for purchasing that. That process may happen. And this is autonomous cars, right? Autonomous cars are nowadays very famous, self-driving cars. With the rise of Elon Musk, people are highly talking about these type of cars, right? Maybe Google, I think Google has framed long back about this, but no specific or significant steps were taken in this part. But these self-driving cars or autonomous cars also include reinforcement learning process. How can we do that? This is 3 different views, right? It is always good. And normally when a human being is driving, he will follow a lane, right? He will follow a lane. And it is always preferred that the person should move only in the lane. He should not, the green color may correspond to a field or something like that, right? So my position in the car, the wheel, should be in such a way it is in the center of the lane, preferably, right? So when I move away, when I am driving, when I move away, I will take again, turn the steering back to come to the steady path again. In the same way, when the machine is there, right, whenever it moves either to the left or the right direction, it is wrong, right? So it gets a negative feedback, and it will immediately turn its steering. It will take an action based on the position and based on the feedback I'm getting. I'm going to take a position and come back to the final original lane. Again, I may go to the left. Again, it is going to be a continuous process. So the car will be taught when it is put into practice, right? When you are sitting in the car in the back seat and nobody is sitting in the front seat, but your car moves. That means the safety of the person is very, very important. Nobody, you cannot stop the car or you cannot do anything. Right? Now, the car should be able to take a decision. So whenever it moves left or right, there will be some mechanism by which it will be learned. It will be made to learn to make a correct decision and move in the correct way. Right? This is another example. And even we have example in the medical treatment process. Right? Normally, people, when you go to a doctor, if you have fever or something like that, they will give you paracetamol, right? And they will send you home. Right? You will not come back to the doctor. Doctor is an input, and he gives paracetamol to you. That is the training weights or the process he is giving you, and his target is your fever should come down. And as expected, he is giving the target. He's not interfering within you. He's not interfering within you. As expected, in 3 days or 5 days time, your fever will come down. Process is solved. This is maybe supervised, or you can put it in the unsupervised category. But when you go for reinforcement learning, there will be a continuous monitoring. Say, for example, for diseases like diabetes or some hypertension, right, or heart issues, right, they should be continuously monitored. My target is to make him completely healthy, right? But that is not important. How I'm going to do that? Because I cannot cure diabetes or hypertension with a paracetamol. With one action, it is not possible. So what I do, I give some medicines, ask him to take that, then he will come back again. I will check the pressure or diabetes, and then I will give a decision. Okay, we will change this. Then again, ask him. If you are having some grandfathers or grandmothers in your home, you must be knowing, right? They will have a frequent checkup. So for autoimmune or complex or what should say long-term diseases, chronic diseases, deep learning, reinforcement learning is much preferable than when you go for unsupervised or supervised methods. So the applications, what we are seeing is beneficial, but the way in which it is going to be implemented still needs lots and lots of answers. So that's what you must know. This is enough for you to understand about reinforcement learning. If you are interested, you can explore further and you can ask me doubts. Right? Andrew Ng. How many of you heard about him, Andrew Ng? Okay. How many of you know Mahatma Gandhi? How many of you know Mahatma Gandhi? No answers? Yes or no?
Sir.
Everyone.
Yeah, everyone. Because
Everyone.
father of Mahatma Gandhi is the father of our
Nation.
right?
Nation.
And if I ask you Jawaharlal Nehru, you will say yes, I know. If I ask you Joe Biden, you will say yes, I know. If I ask you Sachin Tendulkar, you will say yes, I know. If I ask you Shah Rukh Khan, you will say yes, I know. How many of you know Andrew Ng? Andrew Ng? No. Okay. So you must know him, all right? Because he is said to be the father of machine learning techniques. Father of machine learning techniques. He, along with 3 or 4 people, are ruling the complete ideology behind machine learning, and specifically deep learning. There is another concept we are not going to see in your syllabus. We have an advanced subject maybe next semester or something like that, where we can see that. But he is the pioneer in framing all these machine learning techniques. And you would have received many mails from our department, right? You need to join some online courses, or maybe from our computer center, and maybe one among them is Coursera. I'm not sure how many of you have heard about this Coursera. He initiated that one, right? Co-chairman and co-founder of this concept of Coursera, where he can disseminate knowledge about machine learning to all the people across the world in an easier way. Maybe you can also try some of the courses, or you can search for Andrew Ng. Maybe I think he's a Chinese American. I'm not very sure about it. Explore about him, and his talks are very interesting. If you are interested, you can listen to his talk, specifically in some conferences like NIPS, Neural Information Processing Systems. It will be very interesting, right? But that is okay. That history is okay. But the thing which is important is what he told, right? The excitement and the hype, right? Whenever something happens, the media will give a huge hype. The excitement and the hype behind reinforcement learning is a bit disproportionate, right? Is it worth? Is the reinforcement learning really worth the hype which is created by the society, right? He says that it turns out that reinforcement learning is a type of machine learning whose hunger for data is even greater than supervised learning. Data, 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 right? No data, no machine learning. No data, no human being. It is not about living with your heart or your kidneys or lungs. The more important parts of your human body are the 5 sense organs, right? You have your eyes, nose, and all other sense organs, which is going to feed you some data. So that is very, very important. But collection of data is very, very, very difficult. Medical data, you go to the doctors, you need to go to them millions of times, only then you will get the information. But he says reinforcement learning is having more hunger for data, which even greater than supervised learning. It is really difficult to get enough data for reinforcement learning algorithms, right? So there is more work to be done to translate this for a real-time application. For a real-time application. Supervised and unsupervised, more or less 95% of them are concrete, right? But when you go into reinforcement learning, still a lot of things need to be done. Then you should study that, then you come for a different process. That's why I told you it is in the higher level or maybe in a research level for practical implementations. But anyway, whatever information you have got, it's sufficient for you to get an idea about reinforcement. If you're interested, you can go through many blogs or websites where you can collect more information about reinforcement. But for our content-wise, I think it is more than enough for you. You must be in a position to distinguish the differences between supervised, unsupervised, and reinforcement. If you can do that, if you can take a paper and write at least 6 to 7 points, differentiating these three things, then I can boldly say that you have understood the concepts of all these things, which is very, very important when we go further into the algorithm. Let me take the attendance. Amulya?
Yes, sir.
Judson?
Yes, sir.
Samyukta?
Present, sir.
Angel?
Present, sir.
Avan?
Present, sir.
Glory?
Yes, sir.
Kiran Kumar? Kiran Kumar? Okay. Kiran Kumar absent. Manideep?
Yes, sir.
Bhanuteja?
Yes, sir.
Jennifer? Jennifer, yes, okay. Priyadarshini?
Yes, sir.
Afreed?
Present, sir.
Jayant?
Yes, sir.
Vikas?
Present, sir.
Alfini?
Present, sir.
Bhuvaneshwar?
Present, sir.
Sumant Kumar?
Present, sir.
Ramesh Kumar?
Present, sir.
Neeraj Kumar?
Yes, sir.
Zubair?
Yes, sir.
Kirti? Kirti? Okay. Dinesh?
Present, sir.
Tejaswant?
Yes, sir.
Chandana Priya?
Present, sir.
Karthik?
Yes, sir.
Vijay Kumar?
Sir.
Janish? Janish? Okay. Vimal?
Yes, sir.
Harshavardhan?
Yes, sir.
Uday?
Yes, sir.
Sakib?
Yes, sir.
Siddharth?
Yes, sir.
Praneeth?
Yes, sir.
Salomi?
Yes, sir.
Libinson?
Yes, sir.
Alan? Alan Joshua? Okay. Ronan? Ronan, okay. Sai Kiran?
Yes, sir.
Joshiba?
Yes, sir.
Shiny? Shiny? Okay. Jasmine?
Yes, sir.
Celestine?
Yes, sir.
Jayasuriya?
Yes, sir.
Joanna Paul?
Yes, sir.
Manasa?
Yes, sir.
Ashrita?
Present, sir.
Narasimha Reddy?
Yes, sir.
Puneet Kumar?
Yes, sir.
Shiny?
Yes, sir.
Joshua?
Yes, sir.
Nagakiran?
Yes, sir.
Suraj? Suraj? Suraj absent. Maunika?
Yes, sir.
Sir.
Topic?
Present, sir.
Suraj, don't be late. Okay.
Sir, I had network issue.
Okay. Maunika?
Yes, sir.
Taufik?
Yes, sir.
Manideep,
Present, sir.
Dikshit,
Yes, sir.
Maria Angel,
Yes, sir.
Amrut,
Yes, sir.
Pavan Kalyan,
Yes, sir.
Sainath,
Present, sir.
Gautam,
Present, sir.
Jagat Chandra,
Present, sir.
Vivekananda,
Yes, sir.
Shashank,
Yes, sir.
Sai Ganesh,
Yes, sir.
Gopi Chand,
Present, sir.
Ritvik,
Yes, sir.
Solomon,
Yes, sir.
Sudarshan,
Yes, sir.
Sujit Kumar,
Present, sir.
Suresh, Suresh Kumar, okay. Sunny,
Present, sir.
Amrita Das,
Present, sir.
okay. So we have one absent today, Kiran Kumar. Kiran Kumar is there? No. Okay, students, thank you. The next session.
Sir,